I'm going to introduce Kyra Wolf, who is a PhD student here at the University of Montana.
Cool, thanks, Kim. Here, let me go ahead and share my screen. Get this set up. Awesome. Yeah, thank you so much for having me here today. I'm going to talk, just give a super quick overview of changes to wildfire in forest ecosystems specifically. And so thinking about different ecosystems, we think of forests as generally occupying the more productive sites, right? And particularly in moist forests, they have abundant fuels. And so in forests especially, climate is a really key driver of fire activity because it dries out those fuels and enables fire spread and easier ignition. And so a really key metric that we think about is vapor pressure deficit, which is basically a measure of how warm and dry the air is and how easy it is for fuels to dry out. And we've seen a trend over the past several decades of increasing vapor pressure deficit, or VPD, which you can see on this map here, especially in the Southwest and the Rocky Mountains, with this significant positive trend in VPD. And VPD is expected to continue to increase as temperatures rise in the future. And we see this really strong relationship between forest burned area and vapor pressure deficit. So with changing climate, as long as there are fuels available to burn, we can expect increased fire in our forests with warmer and drier climate conditions. And those fuels are expected to remain abundant at least through mid-century to support this increasing fire activity. And not only do we see a positive trend in total area burned, but we also see an increase in high severity fire. So this is a study that looked across the Western US and in specific ecoregions to look at trends in forest fire area and area of high severity fire. And we see here, there is a significant positive trend in total area burned and area burned at high severity with that purple line there since 1984 in Western forests in general, and that's true for the North Central Cass region as well. And so that makes sense, right? We're having more fire, therefore we should also be having more high severity fire. But what this study found is also that vapor pressure deficit is positively correlated with sort of average fire severity and the proportion of area burned at high severity. So with warming and drying, we can also expect an increase in high severity fire in our forests as well. And these trends are particularly evident in high elevation forests. These are areas that are typically, in most years, too wet to burn, right? They're cold, they're moist, and that moisture creates a barrier to fire on average. However, that warming and drying that we've been seeing over the past several decades has allowed an upslope shift in sort of the uppermost extent of fires on average. And that's shown here in this map. So this is the trend in the uppermost extent of fires across the West. And we see those increases are the most pronounced in the Sierra Nevada, the Central Rockies, and in the Southern Rockies. And so these subalpine forests are particularly sensitive to climate-induced increases in fire activity. And in fact, some subalpine forests may actually be exceeding the historical range of variability in terms of fire regimes. And this is a study that myself and some collaborators conducted in this landscape in northern Colorado and southern Wyoming, which had a uniquely dense network of paleofire records. And we used those records to reconstruct past fire activity in this landscape going back about 2,000 years. And found that the expected average time between fires was about 230 years over that period, with a maximum in the rate of burning during the medieval climate anomaly, which was a warm period over several centuries. And comparing that to today, we found that increases in temperature in the 21st century have led to a sharp uptick in fire activity in this landscape in particular, with an average expected time between fires of about 117 years over the 21st century. So at least in this particular landscape, we have exceeded that historical rate of burning. And what that means is that not only are we sort of moving outside the range of conditions that we have, as a society have experienced in the past and come to plan on and expect, but also our forests are moving outside of the range of conditions that they've developed with over at least the past 2,000 years. And so one adaptation implication of that is that our forests are increasingly vulnerable to vegetation transformations, where they're experiencing more wildfire and altered post-fire climate conditions, which can inhibit post-fire tree regeneration. And we see that across the North Central Cass region with this is a study that brought together data from all these different sites across the region. And they compared post-fire climate conditions from the late 20th century to the early 21st century, and found this trend of, on average, warmer and drier post-fire climate conditions and reduced tree regeneration. So with increased wildfire in our Western forests, we can expect changes in vegetation. And just super quick before we move on, I do just want to mention, I've talked a lot about subalpine forests, which are very sensitive to climate conditions. Climate is also a really important driver of fire activity in low elevation forests as well. But we also have some of these additional effects of land use legacies and fire suppression in these low elevation forests, where we see this very consistent pattern across low elevation forests in the West of a fire deficit over at least the past 100 years or so of reduced fire activity, which changes fuel structures and fuel amounts and can alter fire behavior when fires do escape suppression in these forests. And I will leave that there.